Hi, my name is Mohammad Iftikharuddin. Today, our presentation is about Riverview Bypass Road Pavement Construction Project. Project Overview. The Riverview Bypass Construction Project aims to build an 8-kilometer road around Riverview, a bustling town with 20,000 residents. Riverview is a vibrant community with numerous shops, schools, and hospitals. Given this high level of activity, the new bypass road is essential for keeping traffic moving smoothly and enhancing safety for everyone. This project is vital not only for the resident of Riverview but also for people traveling through the area and for trucks carrying goods. By diverting through traffic away from the town center, we can reduce congestion, decrease travel times, and improve overall safety for pedestrians and drivers alike. To ensure effective connectivity, there will be two intersections where the new bypass road will connect with the river highway. These intersections are strategically planned to facilitate easy access to and from the bypass, further enhancing traffic flow and accessibility. Key feature of the Riverview bypass. The total length of the Riverview bypass road is 8 kilometer, and northern section it's 3 kilometer, which is located in a low-lying area. And other side of the northern, the southern section, this is 5 kilometer, and we'll have two intersection, northern intersection and the southern intersection. Now we'll discuss about the field data of the northern section and the southern section. So the northern section, it's locating in a low-lying area adjacent to the Black River, and we have a crossing there with the Black River where we need the multi-cell box culvert. And the soil condition there is very poor, silty clay, sensitive to moisture. And we have the design traffic, and the subgrade severe is 4. On the other side, the southern section, it's locating in a higher ground and highland, and that soil quality compared to the northern section here is much better, which is dense sandy soil. And we have the design traffic, and the subgrade severe is 12. Now the geometry of the northern section and the southern section. Uh, Northern and southern section will have a 7 meter wide single carriageway with one lane for each direction, where the lane width will be 3.5 meter. On both sides of the carriageway, we'll have a 1 meter wide sealed shoulder, followed by a 0.5 meter wide unsealed verge. Uh, for the northern section, the embankment slope towards the table drain will be 1 in 4 on each side, reducing to 1 in 2 after the table drain. Um, However, for the southern section, the table drain will be 1 in 4 on each side and maintain even after the table drain. Um, uh, to accommodate this space, the northern section we will have a 40-meter road reserve because of the embankment construction there. But for the southern section, we only need 20 meter. Here is the cross-section drawing of northern section and the southern section. So we already described here. You can see for the northern section we need 40-meter road reserve. For the southern section we only need 20-meter. Now the pavement thickness. So based on the subgrade severe and the design traffic, we can calculate the pavement thickness from a chart provided in the OS road guide. Uh, is the part 2 pavement structural design. Um, so for the northern section, CVR4 and with the design traffic, the pavement thickness would be 550 mm. Whereas the southern section with CVR12 and the design traffic, its pavement thickness will be 300 mm. Subgrade treatment for the northern and southern section. Southern section, we have poor quality soil where we need the subgrade treatment, and we'll select the lime stabilization as our subgrade treatment there, as this is the most suitable and cost-effective method for the northern section as per the site condition. And we'll have 250 live stabilization there in the northern section, and the minimum compaction after the treatment would be 95%. Um, uh, um, the other side, the southern section, as we have a better soil quality there, we don't need any treatment. Uh, the primary focus on that section, the southern section, will be to achieve the optimum subgrade compaction to meet the standard, and the minimum compaction for this section will be 98%. Now we'll discuss about the pavement construction. For the northern section, we'll need a embankment before the granular pavement installation, because it's in a low-lying area. So initially, uh, we'll remove 100 mil topsoil, and we'll stabilize the subgrade with the lime stabilization, and then we'll construct the embankment, and the height of the embankment will be 2 meter. We'll use the select fill material for this embankment. Each layer of the embankment will be compacted to a thickness of 150 mm with a minimum compaction of 98% to meet the standard. And the pavement will be constructed over the embankment, and the subgrade and the subbase will use for the subbase we'll use DGB 40 material with the required thickness of 400 mm, and the minimum compaction will be 98%, and the base layer will be DGB 20, and the thickness of the base is 150 mm, and it will be compacted to a minimum of 100%. Whereas the southern section, we don't need any embankment, and initially we'll remove 100 meter topsoil, and we'll compact the subgrade and after that we'll start building the pavement over the subgrade. And the sub base will be DGB 40, where the thickness of the sub base is 150 and the minimum compaction is 98%. And the base layer will be DGB 20, 100 thick, 150 thick, and the minimum compaction for this layer is 100%. Surface drainage for the northern section and southern section. So we'll have a trapezoidal table drain to drain out the surface water of the road. Uh, the maximum slope of this table drain will restrict to 1 in 4 to ensure the stability. But there's exception in the northern section. Table drain slope near the road easement we'll have a maximum 1 in 2 slope there because of the space constraint. And the longitudinal slope of this table drain will be in between 0.2% to 0.6% to ensure the continuous flow of the water towards the Black River. And to prevent the erosion, the flow velocity in the grass channel will be kept within permissible limit, and erosion control cutoff wall will be installed at regular intervals. And for the access, because we have few farms, they are especially they are the southern section. So for those farms, we need to have the pipe culvert over the table drain to make sure the continuous flow of the water of the table drain. Now I will discuss the access point for the Riverview bypass, focusing on both the northern and southern section. Starting with the northern section, this area is characterized by its bushland setting and lack of nearby residential properties or farms. Due to its remote location, there is only a single access point. To ensure accessibility, will be installing a reinforced concrete pipe culvert, which will include head walls on both sides of the access road. Uh, the road itself will be sealed up to the end of the table drain to provide a durable surface for vehicle. Additionally, we'll install guideposts on both sides of this short seal road to enhance safety and navigation. And moving on to the southern section, this area is quite different as it contains several local farms that require regular access. To accommodate this need, we'll also install a reinforced concrete pipe culvert with head walls on both sides of the access road, mirroring the design used in the northern section. The access road in this section will similarly be sealed up to the end of the table drain to ensure a smooth and reliable surface. Guideposts will be installed on both sides of this road as well as to provide clear guidance and improve safety for all users. The Black River crossing in the northern section of the Riverview bypass necessitates the installation of a concrete box culvert. For this purpose, we will utilize a multi-cell precast box culvert which offers durability and efficiency. The installation process involves several key steps. So, number one, to facilitate the installation, we'll first construct a temporary barn. This will help manage water flow and create a dry working environment. Number two, the base will be prepared using stabilized sand to ensure a solid foundation for the culvert bottom panel. This is crucial for the structural integrity of the entire installation. Number three, once the base is ready, the bottom panel of the precast culvert will be carefully placed. And then next step involves installing the combined side and top panels. These will be securely fitted together with the bottom panel to form the complete structure. And then after the panel are in place, the joints will be meticulously sealed to prevent leakage and ensure durability. The surrounding area will then be backfilled and compacted to provide additional structural integrity. The last step would be the scur protection. To protect the culvert from scur, riprap and concrete apron will be installed at both the inlet and outlet. This will help prevent erosion and maintain the stability of the culvert. Now let's turn our attention to the asphalt and sealing work plan for both the northern and southern section of the Riverview bypass. The project involves applying a 14-7 double-double seal in the northern and southern section. These aggregates will be sourced from nearby quarry sites to ensure we use high-quality, locally available materials. This approach not only guarantees the quality of the work but also supports local business and reduce transportation costs. To facilitate the efficient distribution of aggregates during the sealing process, we have strategically selected three stockpile locations. These sites will allow us to manage and distribute the materials effectively, ensuring a smooth and uninterrupted workflow. The sealing work covers an 8-kilometer stretch and is planned to be completed over just 2 or 3 days. This tight schedule is designed to minimize disruption and ensure the project progress efficiently. Additionally, to optimize the application and performance of the bituminous binder, a cutter will be used as needed based on weather condition. This flexibility ensures that the sealant adheres properly and perform well regardless of environmental factors. Now we'll discuss about the key work item and the resource requirement for northern section and the southern section. Number one is the topsoil removal. In northern section, we have 12,000 cubic meter topsoil removal, and in southern section, it is 10,000 cubic meter. Subgrade stabilization in northern section, we have 30,000 square meter stabilization, and the depth of the stabilization is 250 mm. Whereas the southern section, we don't have any subgrade stabilization, but we have to prepare the subgrade, and the area for these is 50,000 square meter. We have a select fill in northern section as we are building the embankment, and it is 160,000 ton. And then for the sub base, we'll use DGB 40. For northern section, it's 29,000 ton, and for southern section is 20,000 ton. As the northern section, the depth of sub base is 400, and the southern section, the depth is 150. For the base, northern and southern section, we have 150 base there, and we'll use DGB 20, and the quantity would be for northern section is 11,000 ton, and for the southern section is 20,000 ton. Box culvert is 12-meter wide. We have one box culvert in the northern section. It will be a precast multi-cell box culvert, and southern section we don't have any box culvert. Pipe culvert with the head wall and RCC pipe. The dia would be 350 mm and the length approximately 12 meter. Northern section we have only one pipe culvert. Southern section we have six pipe culvert. Line marking, northern section and southern section we have edge line, center line, and yeah, these are the two basic. So the quantity wise, the northern section approximately 9,000 meter, and southern section it has got 15,000 meter. The road sign, we have few speed signs there in both northern and southern section. Northern section has got 12 and the southern section has got 20 speed signs. Um, uh, 47 double double seal. Northern section is 27,000 square meter, and the southern section is 45,000 square meter. Now we'll discuss about the time requirement for the northern section and southern section for each task. Topsoil removal, northern section, it will take 3 weeks, and for the southern section, it will be 2 weeks. For the subgrade preparation, stabilization for northern section is 3 weeks, and subgrade preparation for the southern section, it will require 3 weeks. Select fill material for the northern section, it's 20 weeks, and sub base for the northern section, it's DGB 40, so it will take 5 weeks, and for the southern section, it's 4 weeks. DGB 20, the base material for the northern section, the time requirement is 3 weeks, and for the southern section, it's 4 weeks. Box culvert, as we have in the northern section, so it will take 2 weeks. Pipe culvert, we only have one in the northern section. It's only 1 week, and the southern section, it will take 6 weeks. The line marking, for the northern section, 5 days. For southern section, it will be 8 days. Road signs, northern section 1 day, 1 day, and the southern section, it will require 2 days. Uh, uh, and the seal work, northern section 2 days, the southern sections 3 days. Now the resource allocation for the northern section and the southern section. Um, we have allocated 3 excavator for the northern and the southern section, 2 grader, 2 pet food roller, 2 multi-roller, and 2 smooth drum roller. And we'll require 5 tipper trucks for these two sections. After the northern and southern section, now we'll discuss about the intersections. So there will be two new intersection in Riverview Bypass Road. One is the northern intersection, the other one is the southern intersection. Geometric design of turn lanes. At both the northern and southern intersections, the turn lanes are designed with a safety first approach. Instead of starting with the full turning lane, with the turn lane begins with a painted median width of 2 meters. This design choice is crucial as it significantly reduces the risk of rear-end crashes. By removing stationary turning vehicles from the main through traffic stream, we enhance the overall safety and efficiency of these intersections. The specific dimension and design standard for these turn lanes follow the channelized right turn treatment guidelines provided by Austroads. These guidelines are tailored to accommodate various design speed, enhancing that the turn lanes are appropriately sized and positioned for optimal performance and safety. The extent of the intersection is 200 meter on the bypass carriageway and 100 meter on the leg of the intersection towards the township of Riverview. This intersection will have 3 lanes, 1 lane for each direction, each 3 meter wide, and an additional 3 meter wide lane for the right turn. And there will be 1 meter wide sill shoulder, like the northern and southern section, on both sides of the carriageway, followed by a 0.5-meter wide unsealed verge. Pavement construction for the northern intersection. Due to poor soil condition at the northern intersection, the pavement thickness will be 550 mm. The new subbase layer will consist of 400 thick DGB 40 material. To ensure pavement stability, a traxial grid and geotextile will be installed beneath the base layer to prevent differential settlement between the old and the new pavement. Uh, Above the traxial grid, a 150 thick layer of DGB 20 will be placed at the base layer. Pavement thickness for the southern intersection will be 300 The new subbase layer will consist of 150 thick DGB 40 material. To ensure pavement stability, a traxial grid and geotextile will be installed beneath the base layer to prevent differential settlement between the old and the new pavement. Above the traxial grid, a 100 thick layer of DGB 20 will be placed as the base layer, like the northern intersection. Now the surface drainage for the intersection. A road surface water will be directed into table drains positioned on each side of the roads. The southbound table drain of the river highway will remain unchanged, except for the installation of a new 450 diameter concrete pipe culvert under the bypass road to ensure uninterrupted water flow. Head walls will be constructed on both sides of the culvert to prevent pavement erosion. To make room for the new right turn lane, the northbound table drain will be shifted westward. Wiring course for the intersection. The two intersection will utilize a dense graded asphalt mix with polymer modified binder suitable for medium to heavy traffic loads. This mix is designed to withstand high traffic loads and provide excellent resistance to rutting, fatigue, and deformation, ensuring durability and longevity. For medium to heavy traffic condition at this intersection, the A10E binder class is recommended for its superior performance. The thickness of the wiring course will be 30 mm. Resource requirement for two intersection. Uh, we have topsoil removal, 1,000 cubic meter, and we'll need 1.5 weeks for these. We have subgrade preparation, 6,000 square meter, and it will take 1.5 weeks as well. We have geotextile and traxial grids, 2,500 square meter, which will take 4 days. And for the subbase, we have DGB 40. The quantity is 2,000 ton. It will take 3 weeks. And for the base, we have DGB 20. We need 1,300 ton, which will take 2 weeks. And we have two pipe culverts, 350 dia, which will take 2 weeks. We have line marking, and we allocated 2 days for these. And the road sign, few road sign, we have the eight road sign, which will take only 1 day. And the asphalt is 2,000 square meter, which will take only 1 day. Now the equipment requirements for the intersections. Uh, we allocate two excavator, one grader, one roller, pet foot roller, and one multi-roller, one smooth drum roller. We also allocate two tipper truck and two mobile traffic lights. The specification that we follow for this project will follow TFNSW specification. For artwork, we'll follow for the material, we'll follow artwork materials. It's for the select field for the SMZ layer that we have for the embankment. For the artwork curtain field, we'll follow R44 and R50s for the stabilization. We have a curtain field and a stabilization work. Stabilization we have in the northern section. For granular pavement work, we'll follow 3051 QS specification for DGB 40 and DGB 20 for sub base and base. Drainage work will follow is a surface it's a precast reinforced box culvert. For these we follow R16. For stormwater drainage we'll follow R11. For a double seal we'll follow R106. For asphalt we'll follow R116. Line marking will follow R141, and the signage work will follow DNC R143. Now the construction approaches. So the construction sequence that we'll have here, we'll start with the northern section pavement construction, and then we'll go to the southern section pavement construction, and after these we will construct the two intersection. First stage is the northern section pavement construction. So we have allocated 38 weeks for this first stage. Uh, we have preparation and site setup, which will take 1 to 3 weeks. We'll have the embankment construction, which will take 4 to 24 weeks, where we have the embankment construction and the all the pipe culvert installation and the table drain preparation as well. Then we have the pavement construction. Uh, Here, week 25 to 37, we allocated for this pavement construction, where we'll construct the base and sub-base layer. And after that, we have the surfacing. It's the double seal, for which we allocate week 38, and after that, we'll proceed to the next stage. Second stage, southern section pavement construction. We allocate 20 weeks for this second stage, and the first step of the second stage is the preparation and the site setup, which will take 1 to 2 weeks, and then the pavement construction and the compaction of the subgrade uh, uh, and all the drainage works. Here we allocate week 3 to week 18. And then the surfacing work of the second stage, week 19-20. It's we'll have the 14-7 double seal here, and then we will proceed to the next stage, the final stage. Final stage is the intersection construction. So we have two intersection here, and duration for these two intersection construction we allocate 10 weeks. The first step here, the site preparation and the traffic control setup, that will happen in the week 1, and after that the intersection pavement construction, where we allocate week 2 to week 9. Here we'll do all the drainage work as well. And then the final surfacing for this intersection. So we'll have our asphalt wearing course, and after this we'll remove all the traffic control measures and restore normal traffic flow. The summary timeline here for northern section, week 1 to week 38. For southern section, week 39 to week 58, and the intersection week 59 to week 68. Now we'll discuss about the safety and environmental control measure for Riverview Bypass project. Uh, First of which is the sediment control measures that will provide. Will provide effective sediment control measure here in this project, which includes the sediment fans, sandbags, hay bales, as per the design. And this measure ensure effective sediment containment and minimizing environmental impact. Now we'll discuss about the roadside vegetation and protected wildlife. We have some remnant vegetation and protected wildlife, especially in the northern section. The northern section, the construction team will follow the review of environmental factor (REF) report to minimize the impact. Measure will include careful route selection, wildlife corridor, and plan transplantation. Construction time to avoid critical breeding and nesting periods, comprehensive monitoring and management plans with buffer zone and sustainable practices, collaboration with environmental experts and conservation groups to ensure effective mitigations. Now we'll discuss about the project safety measures. Uh, we'll ensure critical safety feature to protect workers and the public. We'll provide safety barriers during intersection construction to shield from live traffic. Uh, uh, we'll reduce the traffic speed to 40 kilometer per hour, especially during the intersection construction. And we'll provide portable lighting for enhanced night visibility and safe navigations. Uh, and we'll do the thorough analysis of the dial before you dig documentation to prevent utility damage. We'll also have some pothole investigation if we need. Uh, and we'll monitor the risk register weekly to proactively manage and mitigate any potential risk. And we'll review the incident report register in daily basis just after the toolbox meeting, so that we can promote safety awareness and address concern promptly. We have reached to our conclusion. Um, this project aimed to improve safety and efficiency around Riverview. Um, our approach is grounded in adherence to the Transport for NSW, TFNSW specifications and guidelines, ensuring that every step of the project meets the highest standards of safety and quality. We recognize the importance of the sensitive ecosystem and challenging soil conditions, especially in the northern section of the project area. Uh, to address the sensitive ecosystem concern, we'll implement strategies detailed in the review of environmental factor (REF) report, which includes measure for roadside vegetation and wildlife preservation. This project will be meticulously planned and executed in phases to minimize disruption and ensure that each stage is completed efficiently and safely. We anticipate that the project will take approximately 68 weeks to complete. Together, we are paving the way for a safer and more efficient future for Riverview with this project. That's the end of our presentation today. Thank you.